All right, hi folks, this is Larry Mussolina. I'm recording a video for Module 4 in Math 181. I wanted to give you an overview of working with sets and some different set operations. So let me get started here. I'm going to come over here to these lecture notes and let's talk a little bit about a set. What is a set? Why do we use them? What are the different applications? Well, we want to be able to collect together related items. We call them elements. For example, I might want to list out the students that are taking this course. So I might write a set, and I could use any name I want to write the set. And we use what are called curly braces to denote the set. So what I could do is, let me scroll down here a little bit to give an example. Let's say I wanted to list out the set of integers from 10 to 20. And I'm going to call it set B. So notice right here, I've listed out the elements 10 through 20. I separate them by commas, and I also put these inside of curly braces. So anytime you list out a set, you do always put it inside of curly braces. Okay? Also, whenever you write out a set, you do not list out duplicate elements. So for example, I would not write the number 10 twice in the set, right? Any element is always listed just one unique time in the set. So going back to my example, let's say I want to list the names of students in this course. I could call it, let's say, names, and list out John, Mary, Paul, etc., separating them with commas and enclosing them in the set of curly braces. This is useful, of course, because I want a roster of what students are in the course. Okay. Now I could have a set that's empty because maybe no one has registered for this course yet. So I could show that as just an empty set of curly braces like that. We would call this the empty set. There's no students yet. There's another way to indicate an empty set, and it's to use a symbol that looks like this. So this symbol is an indicator of an empty set. All right, well, let me scroll down a little bit to give some more information. Okay, so we can have an empty set, as I mentioned. That means a set that looks like just empty curly braces. Sometimes we want to list out a universal set. We use the letter U for that. U would be the set of all possible elements that I could select from. For example, if I was interested in the set of 50 states, the universal set would be listing out all 50 states. Maybe I only want the states that are in the Northeast. I could list out the states in the Northeast separately, but the universal set would be giving me the collection of, all the states I could select from. All right, well, there's another bit of notation here that's a little confusing. It's called set builder notations. Let's talk about this a little bit. There's an alternate way to write out a set. Instead of writing out the set like this, where I actually list out all of the different elements, sometimes we call this roster notation. Roster means a list. Well, instead of writing it this way, because maybe I have many, many elements, if I had hundreds and hundreds of elements, I wouldn't want to list them all out individually like this. So what you could do is rewrite it in a way where you're actually giving the criteria. What defines an element in the set? So if I just give the criteria, that's really enough to specify what elements belong in the set. So here is the way to do it. You write it out to say, I'm going to list out the elements. I'm going to call them N. That's just a way to refer to the elements in the set. And I'm going to put a vertical bar. This vertical bar is, you could think of it as the word such that, or given that, or defined by. What it's saying now is, here comes the definition of what elements belong to the set. So I'm going to say N is an integer, and N has to be between and including the numbers 10 and 20. So it's like I'm giving you the conditions or the criteria that an element has to meet to be in the set. So this is an alternative instead of actually writing out all the elements. Okay, so we call this set builder notation because you're kind of building up the conditions that define the elements in the set. All right, well, one thing we're going to do is work with subsets. Because, you know, if I am working with the set of students in this class, I might want the subset of students that have submitted the homework, or the subset of students that have completed the midterm exam, or some other partial listing. Maybe it doesn't include all the members, but maybe it does, right? Because maybe all students have taken the midterm. Could be that the subset is equal to the starting set. We'll see that in just a second. All right, well, I want to discuss what is a subset. All right, so I'm going to use an example here. Let's use set A as the starting set, okay? So I want to come up with a subset. I'm just going to make up a subset. I'm going to call it subset Z. And subset Z is going to be the elements. I'm just going to pick some elements here. 2, 8, 9, and 10. Right? So all I did is I picked specific elements out of this starting set. So let's call this the starting set. Let me show you a set that's not a subset. Here's a set that's not a set. So W equals 2, 8, 9, and 11. Well, this is not a subset because the number 11 wasn't in the starting set. Right? There's going to be a condition that says every element in the subset must be in the starting set. Otherwise, you really can't consider it as a subset. Okay? Now, here's another subset. I can actually list out a subset. I'll call it S. That is all of these values. I'm going to just duplicate all of the values in the starting set. So this set S is a subset of set A. The only condition on the subset is all of the elements in the subset must also be present in the starting set. Well, this S subset S meets that definition. But there's another definition. It's called a proper subset. A proper subset is a subset, but it has the added condition that a proper subset cannot be the same or equal to the starting set. So Z, that set Z I came up with earlier, is a proper subset because it's not equal to the starting set. This is not a proper subset here. Right? Although S is a subset, it's not a proper subset because it happens to be equal to the starting set. All right, so that's a little bit of terminology. Here's a good video to check out with more examples. Well, one thing we'd like to do is understand the relationships between different sets. You know, let's say I'm teaching a math course and I'm also teaching a physics course. I might want to know, are there students in both courses? Maybe there's a student that's taking both courses at the same time. Maybe there are some students taking math but not physics. Maybe there's some students taking physics but not math. Maybe there's students taking neither of those courses. So I'd like to understand the relationship between sets. And Venn diagrams are a nice way to do that because it's a visual way. It's a graph, and it shows you the relationship between sets. Okay? So let's do a quick example here. Now, the way you set up a Venn diagram is you create a rectangle to start with. And this rectangle we think of as the universal set. So everything inside this rectangle is a member of the universal set. And then I define one set. I'm going to call it set A. All of the elements in set A have to be put in this red circle. And then maybe I have a set B. I'm going to draw it this way. All of the elements in set B have to go in the circle. Now, if there are any elements in both set A and set B, they would have to go in this overlap in the middle here. So let me give you a quick example here. Let's actually use this example. here is a database of customers and the types of books they purchased. Okay, so here is the set of all customers. So I'm thinking of that as the full universal set. Then there's a set of customers that purchase cookbooks. I'm going to call that set A. So set A are the people that purchase cookbooks. All right, well, I'm going to put all those people in this green circle, cookbooks. You might notice I had 4 people, Einstein, Bohr, Heisenberg, Dirac. All 4 of those people are in this green circle. All right, let me go to set B. Set B are the people that bought mysteries. Well, that's going to be this blue circle B, mysteries. Notice there's 3 people that bought mysteries. So notice in the circle B, there are 3 people. But what I want to know is there any overlap between these 2 sets? Are there any customers that bought both cookbooks and mysteries? And of course, the answer is yes. Bohr purchased both. Heisenberg purchased both. So really, those 2 customers are in circle A. They're in set A. But at the same time, they're in set B. So I want to put those 2 customers in the overlap. So those 2 customers are going to go here in this overlap region. Really, those people are sitting in both sets A and B at the same time. If you notice, this overlap is part of circle A, but at the same time, it's part of circle B. Okay, so this gives me a way to visually see the relationship between different sets. Let me give you one more example here. I'm going to add a new person into the set. Let me add a new person, Jones, into the set. All right, but it turns out Jones didn't buy a cookbook. Jones didn't buy a mystery, but he's still a customer. So I want to put Jones on this Venn diagram. So I'm going to put Jones out here, still in the rectangle, but not in circle A, circle B. It's the same with this Milliken, right? Milliken is a customer, but Milliken didn't buy cookbooks, didn't buy mysteries, so we're going to put Milliken out here also. They're still in the rectangle, but they don't belong in circle A and they don't belong in circle B. Okay? So the overlap you could think of as kind of the intersection, right? It's people that have bought cookbooks and mysteries. Sometimes we think of this as like the and connector. All right, well, here's another set of operations we do on sets. We do an operation called union, intersection, and complement. Let me talk about each one of these. You're going to do these examples in the WebAssign homework, but let's talk about these. All right, let's do a quick example here. Let's say I have set A here. These are some different internet providers. And then I have set B here, a different set. So these are internet providers in New York City, and these are internet providers in Philadelphia. Okay. Well, I can form the intersection of these 2 sets because I want to know what operators are working in both New York and Philadelphia. So which one of these ISPs, we call these internet service providers, which one of these ISPs are operating in both New York and Philadelphia? Really, that's asking you the question, what elements are in common between these 2 sets? Well, if you compare them, notice Spectrum is showing up in both set A and set B. And notice also Verizon is in set A and set B. So those 2 elements are in the intersection. So the way we write this is we use an upside down U to mean intersection. So I would write down the intersection is Spectrum and Verizon. Spectrum and Verizon. It's really asking you what's in common between the 2 sets. You can kind of think it as the and. what ISPs are operating in New York and in Philadelphia. Okay, so that's intersection. How about union? Well, union is kind of a different question. What if I said to you, what operators are in both New York City or Philadelphia? We call this the union. And that would be AUB. The symbol U means union. All right, so I want to know what ISPs are in New York City, but in addition, which are in Philadelphia. That's like combining all the elements together from set A and set B. It's like putting everyone in one big set. Well, I'm going to list out all the elements that are in sets A and B, both, right? So we think of this as the word or. You can really think what elements are in both sets. And you can see them listed out here. But remember, you don't list out any repeats. So you don't repeat any element in the set. So even though even though spectrum showed up in set A and set B, we don't list it twice in the union. We only list it once. Okay. All right, let me talk about one other. By the way, let's talk about Venn diagrams for a second, because maybe it'd be useful to understand what is the Venn diagram interpretation of this. Well, let's say I had set A and set B here. So these are all the ISPs. And set A would be here, set B would be here. What elements would go in this overlap region? Well, this overlap region is the intersection. Well, for our diagram, that would be the elements Spectrum and Verizon. Let me write it out. Maybe I can try to write it out to make it a little easier to see what I'm saying here. So here is set A. Remember, these are the ISPs in New York City. And here is set B. These are the ISPs in Philadelphia. Inside this overlap, I'm going to write Spectrum and I'm going to write Verizon. Because those are the two ISPs that should be in both circles at the same time. Because Spectrum and Verizon operate in New York City and in Philadelphia. So the intersection really corresponds to this overlap region. So that's going to be the intersection. All right, but what about the union? Well, if I was to draw this out with a union symbol, I guess I might as well just start over. Let me write out the union using a Venn diagram. All right, so here is my Venn diagram. Here is the New York City ISP. Here is the Philadelphia ISPs. The union really means join everybody together, right? I want all the elements that are in set A plus all the elements that are in set B. So really, any elements that are in these two circles would be the union. So the union is really the combination of any elements in the two complete circles here. All right, well, let's do a quick example of complement. So what is the complement of a set? Well, the complement of a set is all of the elements that are not in a certain set, but still contained in the universal set. Let me give you a quick example of that. Let's say I have a universal set, and I'm going to list out some car manufacturers. So Ford, Chevy, GM, Toyota, Nissan, let's say. Okay, there's others, but these are the only ones I care about. All right, and I'm going to define a set. I'm going to call it set A. Set A are the manufacturers Toyota, Nissan, and Chevy. I want to know, what is the complement of set A? We write that as A with an apostrophe on it. When you see a little apostrophe, it means the complement of A. Really what it's asking you are, what are the elements that are not in set A? Well, here are the elements that are in set A. What are the elements that are not in set A? Well, to answer that, you really have to go back to the universal set to see that. I know Toyota is in set A, Nissan is in set A, and Chevy is in set A. So the only other elements that are not in set A are Ford and GM. So I'm going to put Ford and GM here. So to find the complement of a set, you look for the elements that are not in set A, but you really need to look at the universal set to know that. You might notice if you took A and formed the union with A prime, well, that's going to take you back to the universal set. If you form the intersection of A and A prime, there's nothing in common between A and A prime, right? They're totally distinct elements. That would be the empty set. All right, well, why don't we go and do a few WebAssign examples. By the way, here's a good video with more worked out examples on intersections union. I recommend you take a few minutes to watch that video. By the way, folks, these videos are very short and quick. You know, if you click on this video, it's only 7 minutes long. So that's not going to take you too long to watch those, and it'll be a big help. All right, let me talk about one more set operation, then we'll go to WebAssign. So here's one more. It's called the Cartesian product. What that's doing is you're forming the set of all possible ordered pairs where you take one element from set A and another element from set B. All right, so let's do this example here. It's given me A is the set of phones, I guess iPhone, Galaxy, and Pixel. And set B, it looks like are different memory sizes. So B is the set 64 gigabytes and 256 gigabytes. All right, I want to form what's called the Cartesian product. You saw that with a little X in between. Almost looks like a multiply symbol. So what is the Cartesian product asking you to do? Well, it's asking you to take each element in set A and match it up with each element in set B. And we're going to form a set like that. So this set is going to be ordered pairs. So I'm going to take iPhone and match it up with 64 gig. That's one ordered pair. Here it is, iPhone, comma 64 gigabytes. Okay. Then I'm going to take iPhone and match it up with the other element in set B, which is 256. So that's another element, iPhone 256. All right, I'm going to keep going because now I'm going to go to the second element in set A, which is Galaxy, and I'm going to do the same thing. I'm going to match that up with 64, and I'm going to match it up with 256. So that means I'm going to have Galaxy 64 and Galaxy 256. And of course, I'm going to do the same thing with the last element in set A, which is Pixel. So I'm going to take Pixel and pair that up with 64 gig and 256. So Pixel 64 gig and Pixel 256. And then I've got to close this up with an ending curly brace to kind of close out the set. So I'm going to put an ending curly brace here to match this opening curly brace. Okay. One thing you might notice is there's 6 elements in this ordered pair, right? Here's 1, 2, 3, 4, 5, 6 elements. Well, you'll always be able to figure that out because there was 3 elements in set A, 2 elements in set B. If I just multiply 3 times 2, that's going to get me to 6 elements in the Cartesian product. All right, so those are the different set operations. Why don't we jump into WebAssign and we'll do a few homework problems. So let me come here. We're talking about the Module 4 assignment. All right, let's do a few examples. All right, let's go to problem 1. Problem 1 says list the elements of the set. Well, notice the way they're giving this to me, it's in set builder notation. But they're really asking me to list out the elements. So they really want me to go to that roster notation. All right, so they want me to list out all the elements inside of curly braces. All right, well, I got to go to the definition. It says an element of the set is a positive integer. An integer means a whole number. And it's got to be greater than 20, but less than 21. So I need integers that are greater than 20, but also they have to be less than 28. All right, well, greater than 20 means not including 20 itself. So the integers that are greater than 20 will start at 21. And all of these integers that I'm writing here are greater than 20, but I've got to be less than 28. That means not including 28 itself, so I got to stop at 27. So this definition is really telling me to list out all the numbers starting at 21 and ending at 27, because that's what this criteria is telling me. And of course, I got to put a comma in between all of them. Now, when you go to enter this answer in WebAssign, don't enter curly braces yourself, because notice WebAssign has put the curly braces here for you. Right, so all you're going to do is type in these numbers. I'll circle them in red so you can see it. All you're going to do is type in what's in this red box. Leave out the curly braces because WebAssign has put them there for you. All right, let's go to the next one. Problem 2 is asking you to draw a Venn diagram to represent these sets. All right, well, they're using S to indicate the universal set. So this set up on top here is really the universal set. Then they're showing me 3 sets A, B, and C. Well, when I have 3 sets, I can show it on a Venn diagram as these 3 interlocking, or I should say 3 overlapping circles. So I got to figure out which one of these diagrams is correct. All right, well, let me check it out here. First, let me notice what's in common between sets A, B, and C, because maybe that'll help me out. I'm noticing pomegranate is in set A, B, and C. Well, if pomegranate has to be sitting in set A, B, and C, when you think about this Venn diagram, here's set A, here's set B, and here's set C. I need to put pomegranate in a position here where it's sitting in all 3 circles at the same time. Well, there's only one place where that happens, right here in this overlap. That's the only part of the Venn diagram that's located inside circles A, B, and C simultaneously. So that means I got to put pomegranate in this middle section. So this looks like a possible answer, and this looks like a possible answer. I'm going to cross this out because pomegranate isn't in that middle overlap, so those 2 answers can't be right. All right, well, I got to keep going to try to identify what is the correct answer here. Well, let me go now to set A. If I go and look in set A, I'm seeing gateway, Dell, pomegranate, and compact are all in set A. So those 4 elements have to be in circle A. And here it is. If you look at circle A, all 4 of those elements are in circle A here. So that tells me this must be the correct answer. This one is wrong because they're taking gateway and putting it outside of circle A, but that's incorrect. Gateway has to be inside circle A, right? Just the way Dale, pomegranate, and compact does. So I know this answer here is the only choice that reflects the sets they gave me here. All right, let's take a look at a few more. Let's do a couple of examples here with forming the union of sets. All right, let's go to number 3. It says form the union of set A and C. Whoops. Let me share again. Yep. All right, so we're going to number 3 here. And number 3 says figure out A union C. Of course, I got to remember, what does union mean? Union means combine all the elements together from sets A and C together into like one big set. You know, the word union means combine together. So let's do it. I'm going to put all the elements from set A in the union, but also I'm going to add in the elements from set C as well. But remember, no repeats. I'm not allowed to repeat elements in any set. All right, so let me go grab A. It's going to be these. So it's going to be June, John, Jill, Justin. I guess they like J names, right? Jeffrey and Jelly. Okay, now, so I just took care of all the elements from set A, but I've got to also add in the elements from set C. So here it is. Let me add them in. There's Sally, Solly, Molly, Jolly, and Jelly. But now I'm seeing Jelly is already there, so I'm not going to repeat it. So this is the union that I just listed out. Okay, when I compare the answer choices, it looks like the only answer choice that matches is this first answer right here. All right, let's do another example. All right, let's go to number 4. And without doing this, I'm just going to comment that when you see set operations with parentheses, the parentheses you can think of as like order of operations. I want to do this operation first. So I'm going to combine all the elements from B and C into one big set. Once I have that, I'm going to combine those with all the elements from set A. Well, when you think about it, what's going to end up happening here is I'm going to have all the elements from A, B, and C put into one gigantic set with no repeats, of course. So I'll let you do this one, but you're probably going to see that it's going to match up to set A, right? Because you're going to be taking all of these elements from set A, combining them with all of these elements from set B, combining them with all of these elements from set C, putting those into one big set, but you're not going to repeat any elements, right? For example, once you list Jelly in the set, here it is, you don't list it a second time, you don't list it a third time, you only list it once. All right, let's do a few examples that involve intersection. How about if we come here? This one, let's go to number 6. Number 6 says find C intersection B. So remember, this symbol means intersection. Really, it's asking you what's in common between these two sets. What element is sitting in both set C and set B at the same time? So I got to compare them. Let's see, John is in set B, but not in set C, so I'm not going to use John. Jelly is in both. So Jelly is in common between sets C and B, so Jelly goes in the intersection. Let's see, Jared. Jared is not in set C, so Jared doesn't belong in the intersection. So it looks like the only element that's in both set C and B is Jelly. So it looks like this will be the answer on this one. All right, let's go down and do an example that maybe combines these together. Let's go to number 8 here. So number 8 is a little tricky, but let's write it out. Number 8 here is asking us for A intersection B union C. Well, I got to remember, I got to do the parentheses first. So I'm going to do this first. All right, well, A intersection B is asking you what elements are in common between sets A and B. All right, so let me check it out. I'm going to start here with July. July is not in common because July isn't in set B, so I'm not going to use July. Let me go to John. John is in common, so I'm going to put John in the intersection. How about Jill? Jill is not in common. How about Jared? Yes, Jared is in both sets, so Jared goes in. And how about Jennifer? Nope, Jennifer is not in both. How about Jello? Yes, Jello is in both. All right, now I'm going to union that with set C. Well, I know set C is Sally, Solly. I'll list it out to make it a little easier. Sally, Solly, Molly Jolly. I'd love to know who came up with all these names. And Jello. Well, I remember union means combine everybody together. So I'm going to combine all of these together because that's what union means. Union means join them together. So our big set is going to be John, Jared, Jello. Remember, I'm not going to repeat any. Sally, Solly, Molly, Jolly. But notice Jello, I already have listed. I'm not going to repeat Jello. All right, so let me check my answers here. John, Jared, Jello, Sally, Solly, Molly, Jolly. It looks like it's this answer right here. All right, folks, why don't we do an example of Cartesian product? So let's go to number 9. Well, remember, Cartesian product means take every element in the first set and pair it up with every element in the second set. So what they're asking you to do here is form, remember we call this Cartesian product. The word Cartesian should remind you of like XY ordered pairs, right? If you think back to algebra, Cartesian coordinates were XY pairs. Well, they're asking us here, B Cartesian product with C. So for this, I'm going to list out all of the pairs. I'm going to take yellow and pair it up with pentagon. So that's one element, pentagonal. Then I'm going to take yellow and match it up to the other element, which is round. Okay, so I just took care of pairing up yellow with each element in set C. Now I'm going to come back and do the same with the other element, which is black. So I'm going to pair up black with pentagonal and then black with round. So black, pentagonal, and black round. All right, and I'll just check out which answer corresponds to this. Right, so let's see here. So yellow, pentagonal, yellow round, black, pentagonal, black round. Looks like it's this answer right here. Okay. Let's see if there's any other examples here that we might want to look at. What if we look at number 10 here? This is a little more involved, but let's look at number 10. All right, so they're giving me some different sets for a freelance consultant. All right, so these are all the clients. This is like the universal set here. All right, but then there's a set of clients that owe her money. That's set A. There are a set of clients that have done at least $1,000 worth of business with her. That's set B. And the clients that employed her in the last year, set C. All right, well, here's what we want to do. Come up with a subset of clients based on this description. It's the clients who owe her money and have done at least $1,000 of business with her. All right, well, let's relate it back to the sets they gave us. The set of clients who owe her money, we call it set A. So this is really set A. The set who have done at least $1,000 of business with her, that's set B. The word and means intersection. So the word and means intersection. Intersection is this upside down U. So they're really asking me to find A intersection B. Well, let's do it. If I want to find A intersection B, I'm looking for those elements, really those customers that are in both sets. These would be the customers that owe her money and have done at least $1,000 of business with her. So let me just compare these two sets together. It looks like ACES is in both sets. Cores is in both sets. And I think that's it. So I think the answer here is ACES and cores. Those are the only two elements that are in both set A and in set B at the same time. So here's the answer to this one. All right. Let me see if there's anything. So some of these are very similar. All right. Maybe we could do one more. Let me come back here to a couple of examples here that involve this symbol that involve the empty set. Okay. So let's come here to this one. It says, find B union the empty set. Remember, when you see this symbol here, it's the empty set. So they want me to form the union of B and the empty set. Well, I know B, they gave me that. That's Sally, Solly, Molly, Jolly, and Jello. Okay. Well, I want to union that with the empty set. I'm going to write that as just the empty curly braces, because that's really what the empty set is. Set that has no elements in it. Well, remember what union really is asking you to do. Union means join together all of these two sets. It really says take all of these elements and combine them with all of these elements. But you can probably see this is just going to take you back to set B. Because if I join together all the elements of set B with nothing, well, that's just getting me back to set B. So really, they're asking me to just repeat set B here. So looks like it's this first answer here, set B. All right, folks, I think this should help you get started in the in this WebAssign homework dealing with sets and union, intersection, Venn diagrams, and so on. So please give this a try. Let me know if you have any questions, and hope this is helpful as you're getting started in Module 4.